There is a factory in Fremont, California, where something quietly changed in the last 12 months. Not the cars, not the assembly lines, something deeper. Something that most people driving past that building have absolutely no idea is happening inside. Imagine walking onto a factory floor and watching a robot move. Not the kind of robot you picture from old science fiction. Not a claw arm welding a door panel on repeat. This one walks. It picks up a battery cell, examines it, sets it down in the right place. Then it does it again and again. Around the clock. It does not get tired. It does not call in sick. It does not ask for a raise. And here is the part that should genuinely stop you cold. Tesla has admitted that right now. Those robots are not even trying to be productive yet. They are just learning, watching, collecting data. The work has not even started. Think about what that means. For decades, the dream of a fully autonomous factory existed somewhere between science fiction and corporate fantasy. Big promises, modest results, and an endless parade of robots that could only do one thing in one environment under ideal conditions. The gap between what robots could do in a lab and what they could actually do in the chaos of real manufacturing was enormous. That gap is closing faster than almost anyone outside of a handful of engineering teams fully understands. Tesla's approach to manufacturing has always been different from traditional automakers. While Ford and General Motors rely on networks of suppliers, legacy assembly structures, and factories designed decades ago, Tesla builds as much as possible in-house. Batteries, software, chips, and now the robots themselves. But the real shift is not about vertical integration. It is about what happens when you connect a humanoid robot to the same artificial intelligence that already drives millions of cars on public roads every single day. The neural network that powers Tesla's full self-driving system is not a separate technology from the one controlling Optimus, the company's humanoid robot. It is the same architecture. The same system that has processed billions of miles of real-world driving data is being applied to factory tasks, to movement, to spatial awareness, to decision-making under unpredictable conditions. That connection is not a marketing detail. It is potentially the most important engineering decision in the history of manufacturing robotics, and most people are still treating it as a footnote. By January of 2026, Tesla had deployed somewhere between several hundred and approximately 1,000 Optimus units at its Fremont facility and at Giga, Texas. Their current tasks are relatively simple: sorting 4,680 battery cells, handling parts, quality inspection, pick-and-place operations. Elon Musk himself acknowledged at the start of that year that these robots are primarily focused on learning and data collection rather than performing fully productive tasks. That honesty is actually the most revealing thing he could have said, because it means Tesla is not at the finish line. It is not even in the final lap. It is building the engine that will eventually make the finish line irrelevant. The way Optimus learns is worth slowing down on, because it reframes everything. These robots watch human workers perform tasks from a first-person perspective. That video becomes training data. The robot then attempts the same task, fails, adjusts, and tries again, feeding every iteration back into the system. This is called imitation learning, and it is the same fundamental approach behind some of the most dramatic advances in artificial intelligence over the last several years. The key difference here is that Tesla has 1,000 robots inside its own factories generating that training data around the clock, in conditions no outside competitor can access or replicate. The data flywheel is already spinning. Most rivals have not even found the wheel yet. Powering all of this is a supercomputer called Cortex 2.0. Phase 1, at 250 megawatts of capacity, came online in April of 2026. Full capacity of 500 megawatts is expected by mid-2026. To put that in perspective, 500 megawatts is enough electricity to power a small city of several 100,000 people. Tesla is dedicating that entire capacity to converting factory data into improved robot behavior, not to running websites, not to training a general-purpose chatbot, to teaching machines how to work. Tesla is also converting its Fremont production lines previously used for the Model S and Model X, which were discontinued in the second quarter of 2026, into Optimus manufacturing lines. A dedicated Optimus factory at Giga, Texas is under construction. The long-term production target for that single facility is 10 million units per year. Tesla only sold approximately 1.8 million vehicles globally in 2023. Let that comparison settle for a moment. 10 million robots per year from one factory, compared to less than 2 million cars from all facilities combined. The internal math at Tesla is no longer primarily about automobiles. Capital expenditure tells the same story. Tesla spent approximately $8.5 billion in 2025. In 2026, that number nearly tripled to between $20 and $25 billion. Almost all of it is going toward robotics and artificial intelligence infrastructure. That is not a company hedging its bets. That is a company betting everything. Now here is where intellectual honesty becomes essential, because this story has a shadow side that deserves equal attention. Tesla has missed every major Optimus production target since announcing the program in 2021. The goal for 2025 was 5,000 units. The actual result was somewhere around 300 to 500, less than 10% of the target. Gen 3 mass production only began in January of 2026, and as of that same month, Musk openly stated the robots were not yet doing useful work at scale. That is a significant gap between the vision being sold and the reality being built. Supply chain constraints add another layer of complexity. Each Optimus unit requires approximately 3.5 kilograms of neodymium iron boron magnets, rare earth materials that China moved to restrict through export controls in April of 2025. The disruption was real. And with over 150 Chinese humanoid robot companies now in existence, and Chinese firms commanding 85% of global humanoid robot installations in 2025 compared to only 13% in the United States, the competitive and geopolitical pressure is not abstract. It is already here. Companies like Unitree are shipping robots at prices between $12,000 and $13,500. Agibot shipped over 5,000 units in 2025 alone. Tesla's cost target of $20,000 to $30,000 per unit only becomes achievable at 1 million units per year production scale. Currently, each unit costs somewhere between $50,000 and $100,000 to produce. The distance between aspiration and economics remains vast, and yet, prediction markets currently assign only a 21% chance that a humanoid robot will be commercially available for consumer purchase in 2026. The broader engineering community continues to flag serious unresolved challenges around safety certification, real-world adaptability, and reliable autonomous performance in dynamic environments. No regulatory framework yet exists to govern humanoid robots working alongside humans under OSHA standards or European machinery regulations. The questions are real, and they deserve real answers. So what is the most honest interpretation of everything happening here? Tesla is constructing infrastructure for a future that may or may not arrive on its announced schedule, but that appears genuinely likely to arrive eventually. The critical milestone that will either validate or fundamentally challenge the entire thesis is the second and third quarter of 2026, when Gen 3 Optimus hands are scheduled to be deployed for actual productive autonomous work at Fremont. Not learning, not data collection, real work, 24 hours a day, 7 days a week. If that deployment succeeds at meaningful scale, the trajectory changes permanently. If it fails or underperforms, Tesla will add another chapter to a long history of robotic ambition falling short of robotic reality. But zoom out further, past the production targets and the quarterly numbers, past the competitive comparisons and the supply chain disputes, and something larger comes into view. The Industrial Revolution did not ask permission. The mechanization of agriculture did not pause to let society prepare. The arrival of the internet did not wait for governments, schools, or labor markets to understand what was coming before it fundamentally restructured every one of them. The pattern of transformative technology is not that it arrives gently with adequate warning and a reasonable transition period. The pattern is that it arrives, and then the world reorganizes around what it does. Goldman Sachs estimates the global humanoid robot market could reach $205 billion by 2035. Deutsche Bank sees annual sales of 200,000 units by that same year. Musk's internal targets for that year are on a completely different scale, in the range of tens of millions of units, which most analysts find unrealistic. And yet, every previous technology Musk has been told was unrealistic is currently either in orbit, on a highway, or charging in someone's garage. What should genuinely unsettle you is not the robots themselves. It is the speed of the learning curve. Every hour 1,000 robots spend on a factory floor is an hour of training data feeding back into a system that improves continuously. The gap between where Optimus is today and where it needs to be for fully autonomous production is real. But the rate at which that gap is closing is not linear. It is accelerating. And the infrastructure being built right now, the factories, the supercomputers, the supply chains, the manufacturing lines, is not being built for where AI is today. It is being built for where AI will be in 2 or 3 years. Here is the question worth sitting with, and we genuinely want to know what you think in the comments. At what point does a factory that has replaced 50% of its human workforce with autonomous robots stop being an evolution of manufacturing and start being something entirely new? Where is that line? And are we already past it without noticing? The thumbnail you clicked on said humans may not be ready. That framing is not meant to be frightening. It is meant to be precise. The technology is not waiting for consensus. It is not waiting for policy. It is not waiting for the labor market to develop a 10-year transition plan. The factories are being built. The robots are learning. The supercomputers are running. The capital has already been deployed. What you are watching right now, in whatever imperfect, delayed, overpromised, and under-delivered form it currently exists, is the early infrastructure of a new kind of industry. Not a factory that makes cars with some robots helping. A factory that is, slowly, and then perhaps very suddenly, making itself. If you want to understand what is coming before it arrives, and make sense of the decisions being made right now that will reshape the economy you live in, stay with us. There is far more of this story still to tell, and the next chapter is already being written.